All right, 12.2 geometry, chords and arcs. Again, we're going to focus more on these ideas of chords, not so much on the arcs, okay? But that's what the section's called, chords and arcs. Okay, so for a chord is a segment whose endpoints are on the circle. Segment whose endpoints are on the circle. So notice here, P and Q are both on circle O. Now, just to kind of give you a point of reference, the most special chord is called a diameter. So segment AB is called a diameter, and a diameter is just a special chord, but it does go through the center of the circle. So be aware of that. That diameters are called chords, but there are more basic chords than diameters. And again, those are just segments whose endpoints are on the circle. So there you go. So chord, segment PQ. Again, it talks about the arc. I don't care. So down here, this theorem is the only idea we're going to learn in this section. If a diameter is perpendicular to a chord, then it bisects the chord. So in this picture, AB is a diameter. It is perpendicular to chord CD. Therefore, it bisects CD into segment CE and segment DE that are congruent. Now, we can think of it also backwards. I didn't include this, but if they give you that these two segments are congruent, then you also know that the diameter and that chord are perpendicular. So it works both ways. Okay, so again, I'll put like arrows. It works forwards and backwards. So if you know these two segments are congruent, then you know that A, B, and C, D are perpendicular as well. Okay. All right. Okay, so let's go to edge elastic. This is an edge elastic only section and do a couple problems. Okay, so I got two problems for you. So problem one says, what is the value of r to the nearest tenth? So in this picture, we have a circle, right? Here's r. R is just the radius of the circle, right? Now, in this picture, you have this short segment K and it's dotted, and then you have this chord LM. So LM is a chord that they're talking about. Well, Kn, because K is the center, if I were to extend Kn all the way down, that would be a diameter. And this is the theorem saying that if a diameter is perpendicular to a chord, then it bisects the chord. Well, the entire chord is 14. If 14 is bisected, you take 14 and divide by 2, and that's 7 and 7. And now in this picture here, we have a right triangle. This side is 7. This side is 3. We need to find r. That's Pythagorean theorem time. A squared plus b squared equals c squared. Now in this picture, a and b are 3 and 7. I'll let 3 be a, 7 be b. R is your hypotenuse, c. So I'll do 3 squared plus 7 squared is r squared. Go ahead and type 3 squared plus 7 squared in your calculator. I'm going to do it on my dinky calculator. 3 squared plus 7 squared is 58. That's equal to r squared. And then you have to take the square root to get r by itself. Remember, it would be plus or minus if this was an algebra class, but because it's geometry, we only want one answer, the positive. And the square root of 58 is, it says around the nearest tenth. So for my r value, I got 7.61. This 1 does not change the 6. So your r value is 7.6. There we go. Okay, so we get another Pythagorean theorem problem. All right, let's try the next one. Similar type of problem. All right, here we go. So it says, what is the value of y? So in this picture here, I have a circle. I have a couple radii, right? EB is a radius, and so is AB. This dotted segment is also a radius. Now, we have this BC going through B, and AF is a chord. So this is my chord. Well, notice what's happening here. AF is bisected, 11 and 11, which means that BC, which is a part of this diameter, is going to be perpendicular to chord AF. And here is my picture. Here is my right triangle. Now, R is the same as this r, because in any circle, the radius is congruent all around. So that r is a 15. This is an 11. I need to find y. I have two of the three sides of a right triangle. It's Pythagorean theorem again. A squared plus B squared equals C squared. Now I'll let Y be A, 11 be B, 15 has to be C. So Y squared plus 11 squared, and this could be 11 squared plus Y squared. Again, it doesn't matter, but the right side has to be 15 squared. So Y squared drops down. 11 squared is 121. Use a calculator. And then 15 squared is 225. To get Y squared by itself, you need to subtract 121. Y squared is going to equal 225 minus 121 is 104. And then to get Y by itself, you take the square root. Again, plus or minus, but we ignore the plus or minus, and the square root of 104 is, and it says round nearest tenth, 2.19. That 9 rounds the 1 up to a 2, 10.2. So again, as you can see, more ways to incorporate Pythagorean theorem and right triangles in our life. All right, good luck on this assignment, and we'll see you next time.